we have this 3D shape, and we are going to find out things about this 3D shape like angles and lengths using Pythagoras and cosine rule, given a problem that can be described as this. We need to find dm, so dm being this length here. We need to find bm, bm being the length from here to here. I'm going to go over this again a little bit later. And we need to find the angle between two planes, and we'll talk about specifically which two planes in a moment, but we're going to need to find the angle between two planes. Now, what is most interesting is that the shape perhaps looks quite complicated, but the mathematics behind it, I judge we can do quite comfortably once we've had a little bit of discussion. D is at the top, so this is our D right at the top. And we've got A, B, C around the bottom, A, B, C with D right at the top there. And A, D, B, D, and C, D are 4. So let's apply that information straight away. All the D's, everything linked to D, A, D, B, D, C, D, they're all 4. So C, D here, C, D is 4. So we can put that 4 in there. I want a larger 4. This 4 seems to be a bit like worried about its own height there. Let's take up a bit more room. There's a 4, this must be a 4, and this in here is a 4. So A, D, C, D, B, D, there are 4. Next thing that we're told is that A, B, B, C, and C, A are 6. So what is the description of that? That means A, B is 6. That's nice. B, C was 6, the one in the background there. And A, C was 6. Just to bring that out because M will be in the way. That length there is 6. As well from A to C. The things that might be worth noting is that M is the midpoint, and that we need to be involved in getting the midpoint in surd form. That is what we've been given. So we've got this midpoint here. What can we know straight away? Is that therefore CM has to be 3 because it's the midpoint between a 6, I believe, it's centimeter line. Therefore, we consider this in here is 3. There's a 3 right there. Now, what we're going to do is, in order to find dm, let's tackle dm first. I'm going to utilize Pythagoras' theorem. So I've stated very clearly what Pythagoras' theorem is. It is to find dm, we can use the following. I'm going to use a squared plus b squared is c squared. A and b are the smaller sides of the right angle triangle, and c is the larger side of that triangle. And that is to say, therefore, if I was to say, for example, put a right angle in here to depict that a little bit better, you can see how the right angle triangle pops out at you like, hey, how are you? We have the 3 is the bottom part, so I've done 3 squared. B, we do not know. I do not know what that is, so I'm just going to leave it as B there. Let's get a bit of a more interesting color for that concept. We've got a B there, and that B, to make clear for everyone to see, is the length from here to here. That is a B. That is not a clear color at all. I lied. Let's pick for example a little bit something a bit more intense. That is our B. So we've got 3 squared plus b squared must equal 4 squared, and that's what I've stated. I'm going to take away 3 squared from both sides, which leaves me with this equation. I then square root the both sides of the equation to get b on its own. And thus I end up with b is equal to the square root of 4 squared minus 3 squared, which means that b, which is technically dm, is root 7. And I've stated the units as that is an advantageous thing to do. Therefore, we have root 7 centimeters is dm, and that's tackled quite comfortably. If you look next, however, we also need to find bm, and bm is this. Let's pick a green in here, this line from here to here. Of course, there's your bm. Notice that with this circumstance as well, it might be wise to consider that this is a midpoint, right? So cm is a midpoint, therefore this here from A to M is the midpoint as well. So we know what that length is. Of course, this length is 3. In these circumstances, as you've gone from this point to the midpoint and it's an equilateral triangle, it is comfortable to suggest that in here you have a right angle triangle as well. That line that looks something like, that comes out at you something like that. So you've got a right angle triangle on the base, on that floor there, on that plane. And so we'd have 3 squared plus this 4 is not that green line. This 4 is this line here. So we don't know what that is. We don't know what that is. This green line over here is what we're trying to find out. We do know 6 though. 6 therefore would be the larger side. So I'm going to use Pythagoras again. A squared plus b squared is c squared. 3 squared plus b squared is 6 squared. There's my 6 squared, there's my 3 squared. I don't know what this is. In these circumstances, I'm now calling this line that I don't know b. And so that color is starting to get a bit intense, is it not? So we'll use this and say that line, this green line from b to n, I'm going to call b in this Pythagoras theorem game. So b squared, I'm going to take away 3 squared from both sides, end up with 6 squared minus 3 squared, square root of course. This should be square root on both sides, my apologies, and hence therefore it would be b is the square root of 6 squared minus 3 squared, which is 36 minus 9, which is 27. Root 27 is also 3 root 3. And in these circumstances then for bm is 3 root 3. The length from here to here is 3 root 3. And how I did it, just to go over it again, is I said that the lines, let's use a nice intense color for this part, is that the lines, let's get rid of a large number of this line across here, like so, we'll make it bright red. That line there is a, let's say that's b, let's say this a, so you've got a squared plus b squared will give you your c squared there, and that's how we did it. And so we did a squared, which is 3, b squared we did not know, that's what we're trying to find, and it was equal to 6 squared, and then we did a bit of algebra to produce the concept, not algebra, rearranging per se, probably be better phrase, to root 27 is equal to 3 root 3. And arguably there's algebra. And so we'll stop there before we tackle the next part of this problem.